Hello, sir. My name is Dev Chaudhary and my roll number is 24BC 503. Today I'm going to demonstrate practical number 5 and 6. So first I will start with practical number 5. So in this practical our main focus is how logs are used in digital forensics on Windows and Linux. So first I will explain what is log. A log is a file or record that automatically captures and stores information about events, activities and operations within a computer system, application server or other devices. So these are computer generated logs are also known as log files, which are essential for troubleshooting, security monitoring and understanding usage patterns. So in Windows we have five types of logs. First, we have system logs, then security logs, application logs, setup logs, and Windows forwarded events. So first I'll start with system logs. System logs describe the operating system's health. It includes a driver failing, hardware detection, and which services are started and stopped, etc. So if there is a need to know if machine was rebooted or driver failed around a certain time, we can use these logs. Then we have security logs. In these logs, we have recorded sign-ins, failed sign-ins, permission changes, and audit policy changes. So if we want to identify brute force attempts, suspicious logins, or someone being admin in the group, so we can easily identify. So these are critical entries for proving or disproving unauthorized access. Then we have application logs. Application logs come from programs and services, so they show if an app crashed or misbehaved during an incident, and it mainly shows installation of means program and services. Then we have setup logs. Setup logs are capture software install, updates, and system setup tasks. So if there was anything updated or installed before the problem started, so we can identify, and then it can help with an errors. In forwarded events, we can collect events from other system in a network and we can forward them to a centralized machine for monitoring and analysis. So if there is a need in lab to monitor multiple hosts, so we can use these type of events. I will show where the all the logs are stored. So in the event viewer, if we go into Windows logs, then we have application logs, security logs, setup logs, system logs, and forwarded events. In application log, if we want to filter, then we can filter these logs based on event levels. So if we select critical, warning, and error, so it will show only these three types of events. Uh, it is loading. Okay, filter. So as you can see, we only see error warning type of events. So this is event viewer. Now we are going to shift on Linux logs. So in Linux, we have also five types of logs. First is syslog. So in syslog is the general system log. It shows startup and shutdown messages, service messages, and many other system events. On some systems, the similar file is called messages. Check this first for a big. Now we have Linux auth.log. So auth.log records authentication activities such as failed and successful logins or sudo use. So we can confirm login attempts, username, or sometimes source IP. Now we have dmessage. So it shows kernel messages. It is great for boot messages and hardware or driver issues. If a disk, memory, or network device had an error, dmessage often points it out. And then we have audit logs. So these are generally they record details, security focused events such as system calls. So if deeper evidence is needed, then we can look here. So now this is it for my practical number 5. We I have to also use some tools, and I'm going to demonstrate now journal CTL. So in Kali Linux, we go into terminal. If I want to view all the SSH logs, so I can type sudo journal. First, I will show what is journal CTL. So these are it is showing the logs to every logs. So now if I go and filter SSH logs, so journal CTL slash USSHT service. So right now there are no entries of SSH, but it basically shows or filters SSH log using journal CTL. So now now I'm going to explain practical number 6. In practical number 6, I have done FTP server exploit using Metasploit. So uh, in which I have used Metasploitable and Kali Linux. So I'm going to perform attack from Kali Linux to Metasploit. So now if I go into our machine, so I am going to first of all identify our machine's IP. So IP address of our machine's IP is this. First, let me log in into Metasploitable machine, MSF admin. So we are currently logged into our Metasploitable machine. So now if I want to scan this machine, so I will first check its IP address. So as you can see, this is our IP address of our Metasploitable machine. So now if I run command nmap 192.168.56.101, so it will start the scan. So as you can see, we have port number 21, which is FTP, which is open. So we are going to scan that port. So we will use nmap A 192.168.56.101 slash P to port number 21. Now it will scan port number 21, and now that it has scanned port number 21, so we have this FTP version 2.3.4 vs FTPD. So we will later on search for that. So I will open MSF console now in our Linux machine. So now it is opening. VSFTPD is basically a backdoor which will be using during an attack. So now that we have logged in into Metasploit, so now we will search for VSFTPD. Search FTPD. So we have it is a backdoor which was installed in 2011. So we will use this backdoor to enter into the Metasploitable machine. So now if we use that backdoor, use exploit Unix FTP VSFTPD VSFTPD 234 backdoor. So now that we are using this backdoor, so we will go options, and then we have our host. So we will have to set our host. So receiver host will be set to our machine's IP address, which we are going to attack. So our host 192.168.56.101. So our host is set to our Metasploitable machine. Now we will simply run exploit. So it will attack on the victim's machine. And, now we have entered into our victim's machines. So now we have gained access to the metasploitable, our victim's machine, so we can ls. So these are the all the files in the victim's machine. So if we go into wait, wait. So now, if we have as we have performed ls command, so we can uh, see all the files of our metasploitable machine. Now, if I create some folder or touch, so if I create a file named example.txt, so as you can see, we have example.txt. So if I go into here, cd dot. So if I do ls, as you can see in our victim's machine also, we have created that file. So now, as you can see, if attacker has gained access, so we can also remove logs from our machine. Like he will go to cd var log. In this file, he will manipulate these logs. So if we can access to the or authentication files, so he'll just remove auth.log. So first of all, I will show you what is auth.log. So less auth.log. So as you can see, we have all the data about the session opened, session closed. So it will basically show us that when the attacker attacked the PC, so it will show session opened. So attacker can simply remove the log files such as sudo rm auth.log, I guess. So now if I do ls, there is no authentic auth.log file. So if I go to here and if I want to check the logs of auth.log, simply there is no file of auth.log. So we are unable to scan that file. And if I go here and type in history, so it will show us all the commands executed. So if I don't want the user to show that, so attacker simply will delete clear history using this command. So now if I type history, there is no history. So that's it for my practical number 6.